Okay, we have another new city science relationship, fairly new as of earlier in the year, with Taipei Tech in Taiwan. They are supporting a number of projects, particularly our PEV project. Taiwan has a fantastic bicycle industry. They don't make cars, so it's a nice fit. But we're working on other projects as well, and so Professor Guo is here from Taipei Tech. And the last image that I showed in my presentation, the escape pod had a drop-down bed in this pod where you can nap, and he has done some amazing work on rethinking the mattress. So that's one of the projects that he will talk about. Generally, he has an interest in healthcare, wearables, video processing technology, and he's an excellent collaborator that we have in Taiwan, so welcome. Thank you.
Good morning, ladies and gentlemen. My name is Ziyun Gao. I'm from Taipei Tech. Today, I would like to share part of my research result to you. Just like Professor Ken said that Taiwan is famous for bike industry. However, today, I'm not talking about bike industry. I'm talking about many healthcare. Okay, so first of all, I would like to introduce the so-called intelligent mattress system. However, before I introduce the intelligent mattress system to you, I would like to talk about the problem with conventional mattress. The conventional mattress system is based on the deformation of spring to create the passive support. Under this condition, people may feel lower back pain, or for some portion of the body with larger pressure, bed sore may cause this. So this is our intelligent mattress system. As you can see, we can provide auto-contouring as well as active support in contrast to conventional mattress system. Okay, to do this, to achieve the auto-contouring, we use the pressure sensor as a feedback and use, I'm sorry, it's a video. But it seems that doesn't work. Okay, and use the stepping motor to control the height, that is the position of the nodes. Okay, this is a bottom view of the intelligent mattress system. As you can see, we have 16 basic modules. Each basic module controls 8 nodes, and all the 16 modules are controlled by a microprocessor called Raspberry Pi via Ethernet. That is, the microprocessor Raspberry Pi calculate the algorithm, is in charge of the algorithm and decides the operation of each node. Okay, so under this condition, with this mechanism, we can provide auto-contouring and people feel comfortable on the mattress. Okay, as you can see, the nodes are arranged in a matrix type. Each node can be regarded as a pixel of a digital image. So the overall pressure distribution can be regarded as a digital image. And we embedded the image to HTML. Then we can access the pressure distribution very easily via any kind of browser, for example, Google Chrome or Internet Explorer. And we can also detect the gesture of the user on the mattress. For example, face up, turn left, or turn right, very easy. So we can access the gesture of the user via the browser, okay? And we can access the image remotely. So as you can see, we perform uniform support. Therefore, the pressure comes into a system, okay? And this is the architecture of the mattress system. So the gesture and the status will be recorded in the cloud database, and we can access the status of the user via any kind of browser remotely. And we can also control the operation of the intelligent mattress. For example, perform auto-contouring, perform intelligent mode, and so on. Okay, so what's the application? For example, suppose we can combine with the SpO2, that is the blood oxygen concentration. Then it would be very helpful for the elderly and for those with respiratory difficulty. Okay, and this is another application which can be used clinical. For example, under endoscopy examination, under this condition, we can control which node should go up, go higher or lower down, so that the examination can be performed successfully. Okay, this is another application. We know that the weight of the patient in ICU is very important, but it's difficult to measure the weight of the patient in ICU. But now, since we are using the pressure sensor, and the pressure is directly proportional to the weight of the patient, then we can use the mattress to measure the weight of the patient. And this is for sleep quality. So we can record what time you go to the bed, and when you get up, and how many times you turn over all the night, and you will get a report when you get up this morning. And okay, this is a mattress in S-band origin, Ubrin. I think the director must have referred to our design prior to the movie is produced. Okay. Okay, yeah, this is another project we call Sign Language Translation System, which can help the deaf-mute people to communicate with others. Okay, so we use lots of, for example, flex sensor and inertial sensor, and then to detect the posture and the gesture of the sign language, and the detect posture and gesture are transmitted, encoded and transmitted via Bluetooth to the mobile phone. Okay, and then we have a database on the mobile phone, and we can then apply the Google Translator to translate the vocabulary to voice. So each time when we go abroad, we can choose what kind of language to be used. Okay, this is another smart glove. I'm so sorry. Oh, so sorry. Okay, this is another smart glove we call AirRide. We can trace the trajectory of your hand on the screen, and you can also use a smart glove to control the presentation of your slides. For example, previous one or next one, and you can also zoom in or zoom out by turn your palm clockwise or counterclockwise. Okay, so it's a very easy tool for presentation. Okay. For example, you can use this to replace the function of the mouse. Finally, I will give you a project. So sorry, I think. Okay, so this is about real-time raindrop removal. We also have another dynamic version. I think it will be very useful for video surveillance system or for driving recording system. As you can see, the raindrop can be removed effectively and efficiently. Yeah, that's all. Thank you very much for your attention.
Thank you. Good.